All right, hello again, class. Today we're going to be going over 2.7 on piecewise functions. Okay, so before I start that, a couple things. This is the last lesson on this unit, which means on Tuesday we are going to be reviewing for the test, and on Thursday we will be taking the test. Okay, so this unit has covered things like functions, graphing them, translating them, moving them up, down, left, and right. It's talked about reflections over the x-axis and the y-axis. It's talked about dilations, vertically stretching and compressing functions. And it has talked about circles. And the last part is piecewise functions. What a piecewise function is little pieces of different functions pushed together to make a new function, okay? To talk about piecewise functions, we are going to be looking at a story, okay? So here's our story. It says, Levi works in a shipping and handling department of a manufacturing company. He earns $18 per hour. If Levi works more than 40 hours, it is considered overtime, and he earns 1.5 times his hourly wage for all overtime hours, okay? So, our first question says, how much does Levi get paid per hour during overtime? All right. Well, it says up here that he gets paid $18 regularly, and then after the 40 hours, he gets paid 1.5 times that. So to find his overtime pay, we can just take his $18 that he regularly gets paid and times that by 1.5. All right. That will give us a total of $27 an hour. Okay, so he gets $27 if he works some overtime. All right. Then the second question says, if you were Levi, would you work the weekends to reach overtime? Why or why not? So this is more of like a you question, right? It's a personal question. It doesn't matter if your answer is yes or no, but I want you to write it here and tell me why you think that. Okay? Why would you work to get that overtime pay, or why wouldn't you? All right. Then on question 3, it says, let H be the number of hours Levi works in a week, and W of H be his hour or his weekly wages. Okay? So we're trying to find how much he made that entire week, right? And we're kind of making a function here. All right? So this first one says find W of 15. So in other words, how much money did I make, or did Levi make, when he works 15 hours? Okay. Well, he makes $18 an hour, so I can take 18 and just multiply that by the amount of hours he works, which in this case is 15 hours. And that'll tell me how much money he made. In this case, when he works 15 hours, he makes $270, okay? Then, in the next problem, we want to see how much money does he make if he works 40 hours. Okay, well, I can take his hourly wage, $18, and I can multiply it by the amount of hours he worked, 40, and that'll give me how much money he made that week, which is $720. Okay, so if he works 40 hours, he makes $720. All right, so the next one, I have no idea how to say this name, so I'm going to call her Izzy. Okay, Izzy says that the equation for W can be written as W of H equals 18 times H, or in other words, 18 times the amount of hours you work. Do you agree, and explain? Okay, so does this equation work, yes or no? Well, it did up here, right? It told us that's exactly what we did. We did 18 times our hours. 18 times our hours. So for the problems above, this works perfect. Okay, so you can say this equation works for the problems above. All right, now number 5 says, in the first 2 weeks of June, Levi worked 42 and 50 hours respectively. All right? So we need to figure out how much money he made each week. All right, now the question is, can I do what I did up here? Just take my $18 and times it by my amount of hours. So if he works 42 hours, can I do this? And the answer is no, because he makes $18 every hour until he gets over 40 hours. Okay, then his hourly rate changes, and it changes to $27 an hour. Okay, so what we need to do is we need to split this function up. Okay, so for the first 40 hours, I make $18 an hour. Then for the additional 2 hours, I don't make $18, I make $27 for those 2 hours. All right. Now I'm splitting this function into the first part where I make 18 and the second part where I make 27. Now if I do 18 times 40 plus 27 times 2, I get $774 is what he made when he works 42 hours a week. All right, similarly, we have to do that for the next one where Levi works 50 hours, okay? The first 40 hours, he makes $18 an hour. So again, I could say 18 times 40, or I could just say what 18 times 40 is. 18 times 40 is 720, right? We found that up here. Then I could add to that 720 my new rate, which is $27 an hour, and he worked an additional 10 hours, right? Because that 50 minus 40 is 10. So this will give me how much money he makes if he works 50 hours, which is $990, okay? So does Izzy's equation give you the correct pay for these weeks? And explain? Well, no, it doesn't, right? Because it does not account for the overtime pay. So I can say no, it doesn't account for overtime pay. All right, now in number 6, it wants us to make a graph for this function. But notice we have kind of 2 different functions going on. We have a function for the first 40 hours and a function for the second, or for anything past 40 hours, I should say. All right, so that's what makes this a piecewise function. I've got 2 different functions and I'm kind of smashing them together here, okay? So what we need to do is we need to create a piecewise function. Okay, now this is probably the only time you're going to create one. All the rest of the time will give you a piecewise function and you just have to interpret things from that function. Okay, but for this first one, we'll just create it together. Okay, so what a piecewise function looks like. It looks like this giant curly bracket thing, okay? Then you're going to have your first function right here. And then off to the side, you're going to describe when you use that function. Then you'll have your second function here. And off to the side, you'll describe when you're going to use that function. Okay? So in this scenario, our first function was the one given to us. Okay? It is 18h. That is our first function. So I'll come down here and I'll say 18h is our first function. Then I'll put a comma down and I'll describe when I use this function. Okay? Well, I use this function anytime Levi works between 0 and 40 hours a week. All right? So I'll say anytime between 0 and 40 hours a week. That's when I would use this function. Then after those 40 hours, I'm going to need a new function. So let's write down that other function. Okay, we haven't yet explicitly written down what our new function is. So let me do that for you now. Okay? In the new function, we already start with $720, right? Because we've already worked 40 hours. So we're going to start with $720. Then we're going to add to that 720 our new rate, our new pay rate, which is that $27 per hour. Okay, that rate times the amount of hours we worked. Now, how you find the amount of hours looks like this: H minus 40. Okay? The reason it looks like this is because if Levi works 45 hours, I need to be able to just plug 45 in here. And if I do that, if I say 45 is the amount of hours I worked, then 45 minus 40 is 5. And then I'm only accounting for those 5 extra hours that is times by that $27. So maybe that's confusing, I'm not sure. But again, this is like the only time you're going to have to make one of these. The rest of the time, it's just going to be given to you. So I'm just going to kind of brush past that real quick. Now let's talk about when we use this. Well, we use this anytime that Levi has worked greater than 40 hours. So I can say for any hours greater than 40. Okay? So this is what my piecewise function looks like. Now it wants me to graph this function. Okay, well, I need points to graph this function. The first point I'm going to use, or that I could use, is if Levi worked 0 hours, how much money would he make? He would make $0, right? So at 0 hours, he should make $0. So that's my first point that I can put down, okay? Then my next point I can put down, well, I've already found a couple of points. So I'm going to go back here. It says, well, when he works 15 hours, he makes $270. So I'm going to come down here, and at 15 hours, he makes about $270. So I'll put my point right there. Right? It's not perfect, but that's good enough. Then I've also found how much money he'd make at 40 hours. At 40 hours, he'd make $720. So I'll come back down here, and at 40 hours, I make about $720. Okay? So now I have a couple points. I can make that line on my graph. All right? So there's the first function. Now I need to graph the second function. Okay? To do this, I could use both of these points that I found, but let's just use one for the sake of time. Okay? So I'll put down that when he works 50 hours, he makes $990. So I'll come over here at 50 hours, he makes $990. So there's that point about there. So then I'll connect these dots here. All right. So this is my new function, okay? Now it's not perfect, all right? And it doesn't look like there's that much of a difference here, but there is a difference, right? It is going up a little faster than it was. It seems to be going up at this kind of rate, and then it jumps up and goes a little faster, right? That's what a piecewise function could look like on a graph. There's lots of different ways this could look. That's just one example, okay? Now, for your quick notes, all right, here's the important things that you need to write. In a piecewise function, okay, you're going to have something with this curly bracket. It's going to have equation number 1 and the interval in which you're going to use that, okay? So your first function equation and when you use it. your second equation and when you use it, your third equation and when you use it. And this could go for like 8 different equations. It could be as big as the creators want it, right? Whoever makes it gets to decide how big it is. Usually we just look at them if they're 2 or 3, but they could be larger, okay? The biggest thing that we're going to be doing today on Delta Math is you're going to be given a piecewise function and you have to give me the value or the output from that, okay? So how you do that is you're going to have an input. It's going to be given to you. You're going to plug it into the equation, okay? And then you're going to tell me what the output is. Okay, so that's probably confusing, but trust me, as we go through this, it's going to be pretty simple, hopefully. Okay, so I'm going to jump down to the check your understanding. Okay, a company orders stickers with their logo on it. Okay, the cost of purchasing X stickers is given by the function f of x. Okay, so here's our function. Okay, now number A says, or letter A, excuse me, what is the cost per sticker when you buy less than 100 stickers? Okay, well, let's interpret this function. This is saying that when I buy between 0 and 100 stickers, I pay 23 cents per sticker. But if I buy between 100 and 500 stickers, I pay 16 cents per sticker. And then if I buy more than 500 stickers, I only pay 8 cents per sticker, okay? So question 1, when it's asking what is the cost per sticker when you buy less than 100? Well, if you buy less than 100, then you're in between 0 and 100, right? So this is the interval that less than 100 stickers is in, okay? Which means I'm going to use this function. So the cost per sticker is 23 cents, okay? So 23 cents per sticker. Then for B, it says, find the cost of purchasing 400 stickers. Well, I need to decide which interval does 400 fit into. Okay, so I'm going to say, is 400 between 0 and 100? It is not, so it's not going to be in this first one. Then I'm going to say, is 400 in between 100 and 500? And it is, right? 400 is between 100 and 500. So this is the function I'm going to use. So I'm going to have 0.16 times x, which in this case is 400. Okay, so this will give me the cost of buying 400 stickers. Okay, so 0.16 times 400 is $64. Okay, that's how much it cost for the company to buy 400 stickers. It's $64. Okay. Now the rest of this, check your understanding, is good stuff, but it doesn't really look like Delta Math. So I'm not going to require you to do the rest of this, but what I am going to do is I'm going to go into Delta Math and I'm going to show you how to do the problems on Delta Math, okay? So when you go into Delta Math, you're going to have 3 types of problems, okay? The first problem, it's going to give you a graph, and you're going to have to tell me which graph this is. Okay, this is exactly like your second min-comp question, all right? So looking at this graph, I have memorized all of these, so I know that this is an exponential, okay? So I'll push submit, and I got it right. You're going to go through and keep doing this. This is just practice so that when we do those min-comps, we're getting good at this. Okay, this is a line, so I'm going to say linear. Maybe, there we go. Okay, so you're just going to go through, practice that for your second min-comps, okay? The next type of questions that you're going to have, you're going to be given an equation, or a graph, excuse me. It's going to look like this, and it's going to say find f of 0. What this is saying is when x equals 0, what is y? Okay, So when x equals 0, right here, what is y? Notice I have an open circle here and a closed circle here. Now, if you remember, an open circle means that it is not included in the graph. So this is not a point that counts. But this is a closed circle, which means this is included. So my point, or my answer, is going to be 5, because that's the y value that this point is at. Right? So I will say 5. Well, it's being weird. Say 5, and I'll submit this. Okay, and I got it correct. Now let's look at another one. Okay, find f of 0. Set f of 0 again. So when x equals 0, what is y? So I'm going to look, here's x equals 0, and notice there is no point on this line, right? There's nothing crossing x equals 0. So if there's nothing, then I'm going to say it's undefined, and I'll push submit. Okay. Let's do another one. Let's try to find one that's not 0. Okay. All right. F of 1. Okay, that one's undefined. I think you guys get this one, so we'll just move on to the last one. It's saying, here's your x, find your y, okay? The last one, last type of question, you're going to be given a piecewise function. It's going to say, find where f of 3 is, so it's going to say, when x is 3, what is y? So I need to decide which one of these is my correct interval, okay? So this is when x equals 1, and this is when x does not equal 1. Okay, well, x3 does not equal 1. That is true. 3 is not 1. So I'm going to use this equation right here. Okay, so 3 times my x, which is 3. 3 times 3, which is 9, minus 7. 9 minus 7 is 2. So I'll put a 2 in here and submit. And I got it correct. Okay, now here, when x is 5, what is my y value? So this first one is when x is not 5, which is not my scenario. But the second one is x equals 5. Okay, that's where I want to be because I have x equals 5 here. When x equals 5, y is 2. So sometimes you don't even have to plug it in. It just says, okay, your answer is 2. So I can just say 2. All right. In this scenario, I need to plug 8 in. So is 8 less than 0? No, 8 is not less than 0. So this is not correct. Is 8 equal to 0? No, 8 is not equal to 0. Is 8 greater than 0? Yes, 8 is greater than 0. So my answer will just be -1. Okay. Now sometimes, and let me see if I can quickly find one here. Sometimes you'll end up with a scenario where your x does not fit in any of these intervals. If you end up in a scenario where you go through and you say, okay, it doesn't fit here, doesn't fit here, and it doesn't fit here, then again, you're just going to come down and say undefined because it didn't fit into any of our scenarios, okay? But if you end up in a scenario where it does fit, like 4 does fit in this third one, then you just plug in 4 for x. So you'd go through and do all this with 4 being x, okay? Hopefully that will help you as you go through this delta math. If you have questions, email me or come talk to me next week when I get back.